Hello, welcome to Pre-Cal Section 1.4 Homework Solutions. We'll be going over this worksheet here. So here we go. So this lecture is really in a lot of ways about order of operations. So -5 in parentheses all squared would give you 25. I'm going to do all of these without a calculator. All right, and then -2 squared is going to be 4. All right, so times 4. So that is going to be 100. All right, so we'll have -6. And I'm going to get rid of the asterisk there as I just write it like this. -2 all squared. -2 times -2 is 4. So that's -6 times 4, which would be -24. Okay, so this is 3. I'm going to leave that alone for now. 3 plus 1 plus 2 is 3 squared. Then minus 4 squared. That's going to be 3 plus 3 squared is 9. 4 squared is 16. So that would give you 12 minus 16, which is -4. Okay, so we have 5 minus 2 plus 4 is 6, so that'd be 6 squared, plus 2 cubed is 8. That's going to be 5. 6 squared is 36, so minus 36 plus 8. All right, that's going to be 13 minus 36, which would be -23. All right, I'm going to just leave that -3 out front of the brackets for now. 3 cubed is 27, so that's 2 times 27 minus 50 all squared. So that's going to be -3. So 2 times 27 would be 54, right? So 54 minus 50 is just 4. So 3 times 4 squared. 4 squared is 16. 3 times 16, so that's going to be -48. All right, sure. So make sure to show all of your work on these. I know you could put it all in the calculator, but show all your work. You can check it with the calculator. So we have -3, right? So times 5 times 4 squared is 16, so 5 times 16 minus 3. 5 squared is 25. And then all of that squared. So we're going to have 5 times 16 is 80. So -3 times 80 minus 75. And then all of that is squared. So 80 minus 75. So that's going to be -3 times 5 squared. 5 squared is 25. So -3 times 25 would be -75. All right, so for number 7, move this down just a little bit. I'm gonna want to take this second term and bring it all to the 4th power first. So I'd have -2 x squared y cubed times -8 to the 4th power, and then x to the 4th. So x to the 1st raised to the 4th, you're going to multiply 1 times 4 is 4. So times x to the 4th power. And then y to the 4th raised to the 4th. Remember, when you raise a power to a power, it's multiplication. So that's going to be y to the 16th. All right, so let's go ahead and this is going to be we've got negative 2 times negative 8 to the 4th. Okay, so I'm going to do the non-variable parts, the constant parts first. So that's going to be negative 2 times negative 8 to the 4th times x squared times x to the 4th. You want to have the same base. When you multiply, then you would just add. So 2 plus 4 is 6. So we're adding 2 plus 4. And then y cubed times y to the 16th would be y to the 19th. All right, so if you take in your calculator negative 8 to the 4th, that's going to give you a positive number. And then multiply that by negative 2. That would give you negative 8192 x to the 6th y to the 19th. So you can go ahead and use your calculator to see what 8 to the 4th is. I certainly wouldn't expect you to have that memorized. But negative 8192 x to the 6th y to the 19th is the answer. Okay. And then for number 8 here, we would have negative 5 x to the 7th y to the 6th, and I'm just rewriting that because it's all raised to the first power, and then times, then each one of these components I'm going to raise to the 4th power here. So negative 2 to the 4th times x cubed to the 4th, that's 3 times 4, that'd be x to the 12th. And then y squared to the 4th, 2 times 4, that'd be y to the 8th. So a lot of times students forget, okay, when do I multiply the exponents? When do I add? When do I subtract? Well, when it's an exponent raised to another exponent, that's when you multiply. Okay, so we have this negative 5 out front. So we'll deal with the constants times negative 2 to the 4th. And then we have x to the 7th times x to the 12th. Well, 7 plus 12 is 19, so that's going to be x to the 19th. And then y to the 6th times y to the 8th. 6 plus 8 is 14th, so that's y to the 14th. So I just want to clean up that negative 2 times negative 2 times negative 2 times negative 2. That's going to be negative 5 times 16. X to the 19th, y to the 14th, and then negative 5 times 16 would be negative 80. So we'd have negative 80, x to the 19th, y to the 14th is our final answer. So that's a 19 and a 14. All right, negative 80, I didn't see if I can write a little bigger. X to the 1, 9, y to the 1, 4. So that 4 and that 9 almost look the same there. So that's the final answer on that. Okay. Take just a short break while I erase all this, and we'll go to number 9. So number 9, we are doing division, and with division with exponents you subtract. But we want to get rid of all of the negative exponents. So don't leave any negative exponents. So I've got x to the 4th over 5 to the 3rd all to the 4th power. Okay, so x to the 4th, that's going to be x to the 16th. And 5 to the 3rd to the 4th is going to be 5 to the 12th. And I don't expect you to put 5 to the 12th in your calculator. It's a huge number. This is completely fine on a test to just go with that. You don't have any negative exponents, so that is fine. All right, number 10, we have 3 x to the 4th y cubed. That entire quantity is squared over 3x cubed, and then that quantity is squared. So that's going to be, you're going to take each component and square it. So that's going to be 3 squared. 4 times 2 would be 8, so that's x to the 8th. 3 times 2 is 6, y to the 6th. And then over 3 squared, and then x cubed squared, that'd be 3 times 2 is 6, x to the 6th. So the 3 squared and the 3 squared would cancel out. X to the 8th over x to the 6th, the top is going to win, right? So our final, it's going to be 8 minus 6, which is 2. So you would have x squared on top. And then y to the 6th, there's no y base in the bottom. So y to the 6th. And there you go. So it simplifies down rather nicely there. Okay. No negative exponents. Okay, number 11, we have 2x to the 6th, y to the 4th, all squared, over 2x cubed, all squared. Okay, so let's square this entire quantity. 2 squared, each component, 2 squared. X to the 6th squared would be x to the 12th. Y to the 4th squared would be y to the 8th. 4 times 2 is 8. Then you have a 2 squared on bottom, so that's going to nicely cancel out. X cubed squared would be x to the 6th. So the 2 squared and the 2 squareds cancel. X to the 12 over x to the 6. 12 minus 6 is 6. So that would cancel out, and that would go down to 6. So that's going to be x to the 6th, y to the 8th. All right, I think I can get number 12 in here. So we have 5x to the 4th, y cubed. All cubed, over 5x squared, all cubed. Okay, so we'd have 5 cubed. X to the 4th cubed would be x to the 12th. Y cubed cubed would be y to the 9th. Then 5 cubed. X squared cubed would be x to the 6th. So the 5 cubed will cancel, and then you're left with x to the 12th over x to the 6th. All right, so that's going to be x to the, that bottom would cancel. 12 minus 6 is 6. You'd have x to the 6th, y to the 9th. All right, so very little difference between number 11 and number 12. Probably shouldn't have even assigned number 12, but these problems were written a very long time ago, and I just kept them. Okay, so we've got 4 more to go, 13 through 16. So, give me a second to erase. So don't edit these videos so you end up getting the erase part. Number 13. So again, remember, we are going to try to get rid of all negative exponents. So we'd have 5a to the 7th, b to the 5th, over 25, a to the minus 2, b to the 8th. Okay. So we have, let's deal with the constants first. So we have 5 over 25, right? So that's going to just be 1/5. So I'm not going to write the 1 on bottom, but we'd have 5 there, and that would be a 5. So a to the 7th divided by a to the negative 2. That's going to be 7 minus negative 2. I'm going to just go ahead and write that out. So a to the 7 minus negative 2. And then on the bottom we have b on the bottom has a bigger exponent than on the top, so our b is going to end up on the bottom, and that would be over b to the 8 minus 5 on bottom. So that's going to be 7 minus negative 2 is 9, so a to the 9th over 5b cubed. All right. Number 14. So we have 6a to the 5th, b to the negative 4 over 36 a squared b cubed. Okay, so 6, 36, that leaves a 6 on bottom, right? So we'll have a 6 down here. The a on top is bigger, it has a bigger exponent than the a on bottom, so that's going to be 5 minus 2. So the a squared on bottom cancels out. And then, just like I didn't do that up here, the a to the b to the 5th and the negative 2 ended up canceling out. But you'll have a to the 5 minus 2. And then b cubed is bigger than b to the negative 4th, so the bottom wins on that. So it's going to be 3 minus negative 4 on bottom. Okay, if you wanted, you could move that b to the bottom. It would make it b to the 4th and then add the 2. Either way will work. If you don't like subtracting negative numbers, then move the b to the negative 4 to the bottom and then add 3 plus 4. Okay, but this is going to be a cubed over 6b to the 7th. All right, I think I can fit number 15 in here. So we have 8 cubed, x to the minus 3, y cubed to the negative 4 power over 8 to the 5th, xy to the 4th to the negative 5 power. Now, this is what I would do. I would move this entire quantity up top and change the negative 5 to a positive 5. And then I would move this entire quantity down to the bottom, rewrite it, change the negative 4 to a positive 4. But you can't change any of the signs since it's a quantity raised to a power. All these signs inside the parenthesis stays the same. So we'd have 8 to the 5th, xy to the 4th, to the positive 5 on top, and then 8 cubed, x to the negative 3, y cubed, to the positive 4 on bottom. Now, if you wanted to, you could go ahead and say, make this 3 times negative 4 would be negative 12, negative 3 times negative 4, positive 12. You could go ahead and expand and do that. But I have found that students make fewer mistakes if we do it this way. But when you move an entire quantity raised to a power, you change that outside power sign, but the inside powers have to stay the same. Okay, so this is going to be 8 to the 25th, because 5 times 5 is 25, x to the 5th, y to the 4 times 5 is 20. When I do this, what ends up happening is I have fewer negative exponents to deal with. 8 to the 3 times 4, that'd be 8 to the 12th, and then we'd have x to the negative 12th, and then y to the 12th. Okay, 8 to the 25, so the top wins there, so you'd have 8 to the 25 minus 12. Okay, so we sub 25 minus 12 is division. And then the top wins with the x's, so times x to the 5 minus negative 12, that's going to be x to the 17th. And then the top wins, so the top wins on all three of these, y to on y to the 20th minus 12. Remember, when you divide exponents, bases to same base, different exponent, you subtract when you divide. So that's going to be 8 to the 13th. Just leave it like that. 5 minus negative 12 would be x to the 17th, and then y to the 8th. All right. That's some big exponents. Okay, we've got one more to go. And again, here, if you prefer to just go ahead and expand that to the negative number and then move things, totally fine, as long as you get the right answer. I have students do it this way because I have found fewer mistakes get made, but I don't care if you do it the other way. So finally, number 16, we've got 3 to the 4th, x cubed, y to the 4th, all to the negative 3 power, and that's over 3 to the 5th, x to the negative 5th, y to the 5th, all to the negative 4 power. So since they're both negative, I'm just going to bring the bottom up top, bring the top down bottom, and change the exponent sign of the outer exponent. So all I'm doing is shifting that up top and changing the exponent sign. That's totally legal. Just can't change any of the inside signs. So to the 3rd power. All right, now let's expand. I've got 3 to the 5th to the 4th. That's 3 to the 20th. X to the negative 5th to the 4th would be x to the negative 20. And then y to the 5th to the 4th would be y to the 20. 3 to the 4th cubed would be 3 to the 12th. X cubed would be x to the 9th. And then y to the 4th cubed would be y to the 12th. All right, so this is going to be, the top wins here, 20 minus 12, so that's going to be 3 to the 20 minus 12 on top. The bottom wins with the x's, so that's going to be x to the 9 minus negative 20. And then the top wins with the y, so the y will stay on top, 20 minus 12 also. Okay, so that's going to be 3 to the 8th, y to the 8th, over x to the 29. Wow. All right, brilliant. I hope this solutions video helped you, and I'll talk to you on the next one.